Mount Etna, Europe's tallest and most active volcano, looms over Sicily like a restless giant. For centuries, it's been a symbol of nature's raw power, spewing molten lava, ash, and gas in eruptions that both awe and terrify. But beneath its rugged surface, something profound is happening. Deep within the earth, Etna's magma chamber, the heart of its volcanic fury, is shifting, evolving in ways that could reshape its behavior and the lives of those living in its shadow. Today, we're diving into the science of Mount Etna's magma chamber, exploring why it's changing, what it means for future eruptions, and how scientists are racing to understand this restless beast. Let's start with the basics. A magma chamber is like the engine of a volcano. It's a vast underground reservoir where molten rock or magma collects before it's unleashed in an eruption. For Mount Etna, this chamber isn't a single tidy pocket. It's a complex network of molten pathways, stretching miles beneath the surface, constantly fed by the Earth's mantle. What makes Etna so fascinating is its near-constant activity. Unlike volcanoes that erupt once every few centuries, Etna is always rumbling, spitting out lava flows, explosive bursts, or clouds of ash. This hyperactivity is tied to its magma chamber, which is more dynamic than most. So, why is Etna's magma chamber shifting? The answer lies in the dance of tectonic plates. Sicily sits at the crossroads of the African and Eurasian plates where they collide and grind in a slow-motion crash. This tectonic tango forces magma upward, feeding Etna's chamber. But recent studies suggest the chamber isn't static. It's migrating, possibly rising closer to the surface or expanding into new zones. Scientists have tracked these changes using seismic imaging, which works like an ultrasound for the Earth. By analyzing how earthquake waves travel through the crust, they've mapped out pockets of molten rock shifting over time. This isn't just academic curiosity, it could signal bigger, more explosive eruptions in the future. One clue to this shift comes from Etna's eruptions. In recent decades, the volcano has shown bursts of intense activity, like the dramatic 2001 and 2018 eruptions, which sent lava fountains soaring and ash clouds spreading across Europe. These events suggest the magma chamber is becoming more pressurized, or that new pathways are opening, allowing magma to surge upward faster. Geochemists have also studied the lava's composition, finding shifts in its chemical makeup. Newer eruptions show magma richer in potassium and other elements, hinting at deeper, fresher magma sources mixing into the chamber. This could mean the chamber is tapping into new reservoirs, altering its structure and behavior. But why does this matter? For the 500,000 people living around Etna, a changing magma chamber could mean greater risks. If the chamber is rising, eruptions could become more frequent or intense. A shallower chamber holds less magma, but can erupt more explosively due to trapped gases. Think of it like shaking a soda bottle. Pressure builds until it bursts. In 1669, Etna's deadliest eruption destroyed villages and reached the sea, a catastrophe linked to a highly pressurized chamber. Could a shifting chamber bring similar threats today? Scientists aren't sounding the alarm yet, but they're watching closely. To understand these changes, researchers are deploying cutting-edge tools. Beyond seismic imaging, they use satellite data to track Etna's ground deformation. As magma moves, it pushes the surface upward, creating subtle bulges that GPS and radar can detect. These movements, sometimes just centimeters, reveal the chamber's size and depth. Drones equipped with gas sensors also fly into Etna's plumes, measuring sulfur dioxide and carbon dioxide to gauge magma activity. High levels of these gases can signal fresh magma rising, a warning sign of an impending eruption. By combining these data, scientists are building a 3D picture of Etna's plumbing system, showing how its magma chamber evolves. Yet, Etna remains unpredictable. Its shifting chamber is part of a larger puzzle. Climate change, for instance, might play a role. As glaciers melt and sea levels rise, the pressure on tectonic plates shifts, potentially influencing magma movement. While this link is still speculative for Etna, studies on other volcanoes suggest it's worth exploring. Meanwhile, Etna's eruptions affect more than just Sicily. Ash clouds disrupt air travel across Europe, and volcanic gases contribute to atmospheric chemistry, impacting climate models. A changing magma chamber could amplify these effects, making Etna a global player in volcanic science. The The human side of this story is just as compelling. Sicilians have lived with Etna for millennia, weaving it into their culture, from myths of gods to vineyards thriving in its fertile ash. But the volcano's restless nature demands respect. Local authorities use real-time data from scientists to plan evacuations and protect towns. Farmers and winemakers adapt to ashfalls, turning volcanic soil into a resource. Understanding the magma chamber's shifts helps these communities prepare, balancing life with a volcano that's both a blessing and a threat. Looking ahead, Mount Etna's future is uncertain. Will its magma chamber stabilize, or will it keep evolving, fueling bigger eruptions? Scientists are racing to answer this, but nature doesn't reveal its secrets easily. What's clear is that Etna's shifting face, driven by its dynamic magma chamber, holds clues to Earth's inner workings. It's a reminder of how alive our planet is, constantly reshaping itself in ways we're only beginning to understand. As we keep probing Etna's depths, we're not just studying a volcano, we're learning about the forces that shape our world, one rumble at a time.